I think I'm excited to introduce our guest speakers. So Eliana Fu, industry manager, and then Kevin Slattery, our principal advisor. And we're going to be talking about the future of additive manufacturing. So Ellie and Kevin, if you guys want to join me, we can get started on asking some questions around some of the different, where we're going within additive manufacturing. All right. Thank you guys for joining us today. As always, it's a pleasure to have you guys. And also thank you for your participation within SAE and all that you guys do for us here. The first question that I wanted to ask is, in the last 5 years, what have you seen in terms of additive manufacturing being adopted by the mobility industry? Is it very different when it comes to the automotive sector as compared to the aerospace sector? Kevin, if you want to start with us.
Yeah, sure. The main thing is, for prototypes and many types of tooling, it's now the first consideration because of the ability to integrate the design, eliminate intermediate steps. And so people, can I do this additively for those? And if not, then they move on to something else. The exception being a machine from aluminum solid or something like that. In terms of the difference between automotive and aerospace, automotive, the production rates are much higher. They're willing to pay much less of a premium for performance. And so, whereas aerospace has a higher cost structure, higher cost materials as well, not a whole lot of nickel-based and titanium alloys on cars and trucks. And so, the whole use of additive to reduce your buy-to-fly ratio to save cost is very much an aerospace unique versus a general AM. So aerospace has more ways they can use it. Another kind of difference is that if you look in aerospace, the number of parts produced in aerospace in a production run is about the same as the amount of tools produced in a given year on the automotive side. So they're two completely different volumes of hardware, which, puts them in a different place in terms of the spectrum of AM applications.
Ellie, do you have other thoughts on where you see AM being adopted?
Yeah, I think when you use the term aerospace, it's actually a really large, huge, encompassing industry sector that doesn't just include commercial aircraft or military aircraft, but also includes satellites, UAVs, drones, and space exploration. So space exploration vehicles in particular, I have a particular interest in. And we see a different approach for the use of AM in that sector. It's not just driving down cost or, creating unique designs or reducing part count. It's actually reducing lead time. So what that means is access to space, which we've seen in the news lately, all these billionaires going to space, which wouldn't have been possible without AM processes.
Very timely, isn't it? Thank you guys. So I guess, Ellie, let's start with you then on the next question that I have for you is, what has been the biggest obstacle related to the adoption of AM within all of those industries?
Yeah, for me, it's really process and material related, but also whether it makes sense. So, for example, one of my former employers is a space launch company, and the idea was to create a 3D printed rocket, but not everything can be 3D printed at this moment in time. Not everything can or should be made additively. And so it's what makes sense for that part, the number of parts, the lifetime of that program, or the lifetime of that design. So it's not just one issue or another. They're kind of interconnected, but I feel like what's driving it is what makes sense, or what the urgency or what the end result will be. And particularly in space, if the end result is you're able to fly where you weren't able to fly before, that kind of access to space is what AM is offering, I think.
That makes sense. And Kevin?
And aerospace, sure, stability and repeatability.
Oh, no.
In case of aerospace, it was, it's ensuring process stability and repeatability. that you'll get consistent parts. There are product forms in aerospace that have used on airframes that have never had a failure in billions of flight hours. And that's in some cases what aerospace expects. So showing that a new technology can do that. And on automotive, it's really more about cost and rate when you move out of the tooling realm.
Thank you. And then, so we've talked about the obstacles. What do you guys think have been the big wins in the additive within your different industries? And Kevin, can you share what you think you would consider the big wins are?
Yeah, I've got and picking up on what Ellie said earlier, in space, right? It's the widespread application you're seeing in rocket engines and satellites. There's, in the last 5 years, that's the process of choice. And it's the only process that you can use, right? They're designing them to only use additive. And, those are two sectors where the complexity, cost, performance, and rate structures of those, high complexity, low rates, high premium for performance, really lines up nicely with the current availability in AM. And airplanes, really the initial implementation on large aircraft and engines. There are parts flying. Norse talks about the parts they've had flying. It's been 5 or 6 years they've had them installed on Boeing aircraft. Airbus has some aircraft installed, right? It's really getting them out there and getting those lifetimes. And then this is probably a little bit out of SAE, but it does fall in the mobility as well. The medical industry, the use of engineered AM surfaces to encourage bone and growth on orthopedics, which is personal mobility. It's truly using something that only AM can do to achieve much faster recovery times and much more ultimately reliability in the patient.
I know SAE is looking, we do have some medical content, but not as much as that I think other organizations do, or, what we have with that. But that's a very interesting one, I think. And then, Ellie, what do you think? Or would you say have been the big wins?
Yeah, I think one of the biggest barriers has been acceptance of AM as a legit manufacturing process and not a gimmick. So if you look across any of these industries or any of these, let's say, vehicles or anything like that, whether it's an aerospace vehicle or a automotive vehicle, that AM is not frowned upon. It is not viewed as, oh, that's very strange. Why would you do that? Why wouldn't you just make a forging or a casting like we've been doing for, all these years? So I think more or less maybe just getting over the prejudice of using AM as a gimmick. It's not a gimmick. It's here and it's here to stay.
I think that kind of ties into, Charles had asked a question in the chat, and he had asked, does AM introduce higher risk of counterfeit parts than with traditional manufacturing? So as you had just mentioned, us getting over that initial step there, is this a concern that we should have? Is there a higher risk?
In depending on the industry, right, you need to have a trusted supply chain no matter what. I don't really think it increases the risk. Actually one time one of my former colleagues mentioned his real concern with counterfeiting wasn't people using AM to counterfeit AM parts, but using AM to counterfeit wrought parts. But it comes down to having a trusted supply chain. And, you have to have those, you have to work with people who are on your qualified producers list, right? And you don't buy aircraft parts on eBay.
Yeah, I think that it is an interesting question, but I would argue that for any parts that are not in critical supply chain, let's say maybe they're consumer products or even toys and games and things like that, or crafts, it actually allows people to do some of that at home. For example, I read that Warner Brothers released a whole bunch of files for DC Comics characters that people can print at home. So they don't have to go and buy, the latest hot toy for $200, they could print it at home on their own. I'm not talking about Metal AM here, but that's the other side of the coin. Rather than talking about critical parts and worrying about people smuggling in things or making fake parts, you can actually make home parts for, let's say, non-critical applications. I think that is still a pretty good and maybe a different way of making things or providing things to the consumer, especially if you're talking about consumer products.
Thank you. That's a really interesting about being able to make those parts at home. That intrigues me. And then we do have another question as well from Stuart in the chat. What about Peter Diamandis' vision of additive manufacturing being done on the moon and asteroids to then launch vehicles further outward? Kevin, would you like to start?
Sure. Additive manufacturing brings together material and energy, right? So and of course, material and energy, 400,000 kilometers away are all very expensive. So if it makes sense, that'll happen. But if the moon's made of oxide, right? So you have to have some way of reducing that oxide, and if you don't, then you're just transporting feedstock, to the moon from Earth. So.
Yeah, I kind of have a counter argument to that though, Kevin, because, people are 3D printing structures for the construction industry, and people have been, there's a house that was 3D printed, I think in Austin, Texas. And so people have an idea of one day establishing a human moon base, let's say, and or can they print regolith? So why carry the feedstock with you when it's already there? Now you can make your arguments about messing up other planetary bodies worse than we already have on Earth. That's a different kind of argument. But that's not to say that people haven't thought about it. People have thought about it. And indeed, they're already 3D printing on ISS because we've seen that with the Made in Space. So obviously, the feedstock is much less dangerous or volatile than metal powder, let's say. But the point is, somebody thought of doing it. So people are already thinking of doing it. It's just exactly what Kevin said. What makes sense in terms of energy? So what is that heat source, if you use a heat source, and what is the feedstock? Because you're not going to take metal powder with you. That makes no sense, right? But if you say, I want to print a habitat and I'm going to try and use regolith that's already there, that's a different argument.
Thank you. And Nick, we have quite a few. So thanks guys for sharing your questions with us. Nick had asked, are there any indications that Metal AM will move to an energy input area model with viable power as opposed to the current set power / speed techniques? And Ellie, if you'd like to go.
Yeah, I mean, I can speak from a laser AM machine manufacturer point of view. I mean, it happens that we currently have laser powder bed fusion and laser DED, direct energy deposition, as the two most popular forms of metal AM. But that doesn't mean that electron beam isn't worthy or other methods are not worthy also. We just happen to be able to use materials that we already know that are established from the traditional manufacturing world that happen to be able to be melted and solidified by a laser. And so it's kind of like a coincidence or pretty good luck that all those things work. So we can carry on using 718 or we can carry on using Ti-64, which are two of the most popular materials in aerospace manufacturing anyway. So it's kind of like a stroke of good luck. That's not to say that people aren't looking at other heat sources or processes that are more energy efficient or will drive down the cost, because it's not just the cost of the material or the cost of the process. It's also, we've got to keep in mind the sustainability of the processes. So literally, does it make sense? Could you do it in a more cost-effective way or a less energy-intensive way than making a forging or a casting?
Kevin, do you have some insights?
Yeah. The Velo 3D machines already work on this principle. You can run them one way where you lock down the parameters, but in the sort of the initial way you do it, and the kind of the preferred method is it figures out how much energy it needs to apply, and it's monitoring the system as you're going along, which makes it unique. And the Arcam machines do that to some extent as well.
Great, thank you. And then will there ever be a time when we will see a 50-50 split between AM and traditional manufacturing? That was another question that was asked in our chat as well. Ellie?
Yeah, I mean, from my point of view, I know that there are lots of aerospace companies now that are arguing that they have tons of printed parts or AM parts already flying, but I've got to say that most of those are polymeric, right? So yeah, where it makes sense or where the feedstock is available, because remember, not everything can be printed right now. Some of the materials are still considered unweldable in that kind of sense, or it just has an unavailability in the supply chain. So when things become easier, I mean, we've seen tremendous amounts of blockages in the supply chain, especially during pandemic, and then with the Suez Canal crisis. You can't always get everything that you want. So unless things are redesigned, unless there are new programs, I think it's easier for new programs than existing ones, then yeah, we could get to a point, but only where it makes sense. And it's not just from a manufacturing cost perspective. I think it's also from, what I said about sustainability and like our environmental or shipping costs and those kind of things.
Thank you. And then also, so another question, Gary had asked a question in the chat, but also I think it goes along with another question that I wanted to ask as well. What do you see the next game changer, the next big leap in AM technology, or just within the next 5 years or long term? Where do you see us going? Kevin?
So I broke this down a couple of categories, but the first one is that, overall what you're going to see is in situ non-destructive testing, which is not only monitoring the process, but saying the part is good. You're going to see that becoming more and more common. And it's going to be the standard in it, accepting that there's no discontinuities in the part as produced. That's already available on some machines, and some people are doing that. The other one, and this is much more to fatigue sensitive industries, will be being able to improve the surface at a much lower cost, much more automated. And actually both those are for that.
Oh no.
My connection came back.
Okay.
The other thing is going to be more custom machines that are designed. We're seeing the manufacturers come out with those now. They're coming out with taller machines, double height machines that are much more oriented to a certain product type than before. And better distortion prediction. As you get bigger and bigger, your distortion and residual stress issues go up as a cube function, and so we're going to see better ability to manage that, predict it, and control
it. Ellie, what do you think?
I kind of have a different take on the whole situation. So over the last couple of years, we've seen demand from users, let's say for laser powder bed fusion, higher accuracy, faster deposition rates, all that kind of thing. But what they ultimately want at the end of the day is a bigger machine. So they want to build bigger and bigger and bigger parts. And so we've seen machines getting bigger and bigger and bigger and bigger. But my question is that the right thing to do for that particular process? Because when does it end? So the machines that are now capable of printing 1,000 millimeters in a Z height, like people, they only made those because people asked for them. People want parts that are that big. And so that's fine if the part that you're going to make demands the change in technology to match that. But what it also means is that, especially for laser powder bed fusion, you've got to have a hopper that contains a heck of a load of metal powder. And so my question is it responsible to carry on making machines that are as big as a house? Because when is it going to end? And so I believe that, I mean, this is my personal view, that there's going to be a crossover one day into the ultimate size of laser powder bed where it becomes unsustainable. And so you can argue with me on this topic. I know plenty of people have, to where DED, direct energy deposition, will take over. And now people are going to argue that DED doesn't give me a good surface finish, or it doesn't give me a fine enough spot size and it's a bit more uncontrollable, but you can have a faster deposition rate. So there's going to be a point at which DED becomes better and powder bed becomes unsustainable, because I personally can't see how it's going to be environmentally responsible to keep loading these massive hoppers of powder just to keep the bed filled up. So that's my personal view. It's a bit controversial, but that's what I think is going to happen in the next couple of years. I don't know who's going to do it, but someone's going to do it.
Well, thank you for that. And then we do have another question in the chat from Thu. So there were kind of two parts to this question, maybe three. If we print our own parts, how would it work in terms of maintenance? Who can ensure that the part printed by company A is just as good as company B? And then also, how would it work in terms of cost? What will we pay for the blueprint and own forever, or would it be a license for X amount of parts? Kevin?
Yeah. The whole part about us, part A, company A versus company B, just the same. That all really comes down to your qualification approach you're going to use. And that's one of the things that in aerospace has really gained a lot. In the last 5 years, people have gotten confidence that the methods they're using to qualify parts and evaluate parts, cover everything that has to be, they know they're asking the right questions, which is always difficult. So, you just have to set up your qualification maintenance, make sure you're testing the right things on that part, and also monitoring in production so that you're getting them eternally. As far as licensing, there's many models out there as there are people trying to come up with ways of getting funded. So, and ways of doing it. It's going to come down to a negotiation between the buyer and the seller.
Yeah, I think the question maybe was trying to crisscross two issues. I think one issue would be for, let's say, high demanding parts, whether they're automotive or aerospace, there's not going to be any print at home type of parts. That is going to be a controlled supply chain. There's going to be standardization. They're going to have to meet the customer specifications, and that's going to be the end of the story. If you're talking about print at home parts, which are low value items or low criticality items, which are just maybe things like, I want to print my own hat or something like that, or I want to print a flower pot, that's a pretty kind of low stress, maybe they're not highly stressed kind of components. And there are already free files out there for people to share. People do that kind of thing on Etsy and stuff like that. They make things which are just like, they're not critical components. So I think maybe the question was crisscrossing two kind of issues. I think for people who want to make parts for aerospace industry or automotive industry or medical industry, those things are highly controlled, and you have to be a qualified supplier to take part in that.
Thank you. And then I think some of the questions I'm going to ask you are now about some of the EDGE report. So, you both of you had recently worked together on most recent Edge publication, which is going to be released this month. And this is the fifth in the series for, and Kevin, what got you interested in working on Edge reports with SAE, and how does it differ from a traditional Edge report or a traditional research paper?
So I got interested. There are a number of topics in AM I really thought that needed to be addressed if the technology was going to move forward. I've talked about that already. In NDT and surface smoothing as real obstacles. And then there are a couple of things an example of what the fifth one's about is about sustainability. There's sort of, conventional wisdom that AM is better for sustainability. And I was actually a little skeptical. I said, is it really? And actually in that, right, we address the question and how it can be more sustainable and how you make that evaluation. The real emphasis in this series is helping a product team, apply knowledge and learn things, as they advance in their use of AM.
And then Ellie, what got you collaborating with Kevin on this specific topic?
Well, this is a great question, and Kevin is one of my favorite people in the world. So he actually approached me to review some wording in a previous Edge report of his on surface finishing, and that was when I was at another employer. And I thought, wow, that's so interesting. You can write a paper which isn't necessarily a 5-year-long PhD type thesis. You have the topic. It's a quick topic of discussion with showing different viewpoints. You can put forward various arguments. You can show all these different examples, and then it's quick and easy for people to read and digest. And that's when I think Edge papers are like so cool, because they kind of get across the topic that you want to discuss, and then it opens up because it's an unsettled topic. So there's no right or wrong answer at this moment in time, because especially with AM, we're still learning and we still don't know all the answers. So some of the questions that were posed were, especially on the subject of sustainability, are really timely. And people are obviously, like Greta Thunberg, are very interested in things like sustainability or making our lives more sustainable. And so I think it's not just, doing recycling at home, but how you approach that in, let's say, an industrial environment. What you also have a responsibility as a supply chain participant or a manufacturer or an OEM to think about those kind of topics. And you might not know all the right or wrong answers. There are no right or wrong answers. But the point is that these kind of reports exist so you can have that discussion, or you can read that. And because Kevin is an industry leader here, very respected, and somebody will say, oh, Kevin wrote this, what do you think about that? Go back to their team and discuss it. And then there's different points of view. We also have people help us review the topics who are subject matter experts in those particular areas. And so I think bringing together all those different people and viewpoints puts together a really good little article publication that you can read, digest, and that's thought-provoking. So that's my short answer as to why I wanted to work with Kevin, and I hope I get to work with him again in the future.
Yeah. Personally, I also love the Edge research reports, and I love that it brings about, it starts a conversation on the topic, and I know at SAE, myself and Monica and Will, we love working with our editors too. So thank you guys. And then also you kind of mentioned this, but how it is unsettled, right? So how do you see some of these Edge titles contributing to the future of AM standardization practices though? Kevin?
Yeah. And one thing which really kind of came out, and I really pushed on the NDT and the surface smoothing was, right, getting a common language for the processes and getting rid of that are free of the trade names, and so people can compare the processes and people can develop them and apply them better. There's also some very specific recommendations for industry working groups and specifications to go forward. That once things settle down in these, I work with SAE to actually get some of those established.
Ellie, do you have some thoughts?
Yeah. From my point of view, I just want to say, I think these titles, these edge reports are thought-provoking, and people can use them with their teams to start conversation about the ways in which you can go forward. And so whether that's getting more involved on SAE committees or standardization committees, I mean, there's also ASTM and there's AWS and there's all these other things as well. Being more involved in the conversation so that you are not feeling, like you're just handling this topic by yourself. There's other people out there who have the same questions about the same topic. And it's just a way to bring the conversation together and have people, start from the same page of, I have a problem, I want to know how to address it, how do I get there? And who are the people that I need to bring in to help me? And SAE is one of those organizations that can provide that conduit, I guess.
Well, thank you. Yeah. So I guess you guys are on the committee. So I guess you guys are the ones that would help us support those efforts too, right? And I think we have one more question for you guys. And then what would you say to young engineers who are considering in a career in AM? Ellie?
Yeah, I love this question because I do a lot of kind of STEM research or outreach with, especially with middle school kids. And I think when you allow people to understand that there's a tool or a process out there that can provide a really rewarding career, and it does not necessarily involve, having to do hard graft in a steel mill, for example, although that's where lots of us started. But it is something that's new and changing and evolving. And, if you provide them the imagination or the tool to say, you can be a leader, an engineer, a designer, an entrepreneur, a business owner, or just involved in the industry just to, kind of help the industry along, that can be very rewarding. And if people, especially the underserved communities, don't realize this career path is open to them, they will never get involved, which is really sad.
Thank you. And Kevin, what would you say?
So, it's a quickly evolving technology, and it's going to be part of the future. You still may only see on the products you work on, could only be 1% of the parts are made this way, but it's those parts that are going to be making a difference in how the.
Did we lose him again? Let's give him one more second to see if he can reconnect. Oh no. Okay.
Oh, no. Well, I think I can speak for him when I say that there are now more opportunities in middle school, high school. I mean, I even know there's 6 and 7, 8-year-olds who are 3D printing stuff at home. And so they're learning to use those tools or learning those sort of principles of design or taking things into your own hand. And it's giving people more independence to show that they can do anything they want. And that's the whole point of being an engineer, I think, is to make things better.
I would agree with that. I think that that's also one of the reasons, SE does what they do as well, right? For that. So again, thank you so much for joining us today. I really enjoyed chatting with you. I'm sorry we lost Kevin. Hopefully we can reconnect again. So thank you again. And Angie, you just want to take over?